Right, here we are. All right, so today we are looking at square root graphs. So square root graphs have a basic form of this: y equals the square root of x. So that's our basic garden variety of square root graph. So when we have a look at, here we are, our square root graph there, you can see there, again, this fx is just a, it's called function notation, we'll get to that, but it's y equals, and we'll get to what this one does here. So here we go, there's a basic square root graph, that's what it looks like. So if we go like that there, and that's the +1. Now there is one where you could go negative square root x, and if you do negative square root x, it goes down like that. And then if you put the two of them together, so here we go, keyboard square root x and negative square root x, and you put both of them together and graph them, you get something that looks like a sideways parabola. All right, so that's our everyday garden variety one. But what we can do is we can transform it in a certain way. And in that graphic that I showed you, that's this one here, we can see that there's a number there. So we could have a number out in front there. So we would use that as an a square root. We could have a number in the square root with the x, or we could have some number out on the end. So you'll notice I've used h and k again. So let's go and have a look at this here, square root graphs, and have a look and see. So the a, that's at the moment it's 1, you can see there. So if I make it 2, have a look here, this point here that was at 1, 1, is now at 1, 2. The point that was here at 4 and 2 is now at 4 and 4. All right, so it's been stretched up, and 3, can't quite get it, there we go. So the point there was 1, 1 is now 1, 3. So stretched up in mathematical terms is a dilation. So A is a dilation from our x-axis. All right. So then, of course, that could be negative. So let me slide it down the other way. That negative 1. There you go. So negative. So everything's now down here, the negative. So what we would call that is we would call that a reflection. So if negative, we have a reflection in the x-axis. All right. And then there's the h and the k. So let me take this back to number 1. I'm very good at working with sliders. There we go. All right, the h and the k. Let's move the h first. So the h will be there. Will be a number appears in here. There we go. So now h is 2. So x minus 2 moves to here. So the starting point that was at 0, 0 is now here at 0, 2 and 0. So our h is a translation in the x direction. And as we've discussed before, it moves to when the x value that makes this equal to 0. So x minus 2, that's equal to 0 when x equals 2. So that's why it's moved to there. And let's move that back. And then the k on the end, plus 2, it's moved it up to. Minus 2 moves it down to. All right, so our k, I won't squeeze it in there. I'll squeeze it, I'll put it up over into the next page. So the k is a translation in the y direction. All right. So let us now have a bit of a look at an example. But before that, I'll just point that out again. Here we go. Wrong thing. I'm going to point out here our starting point. So now our starting point was 0, 0. It's now 0, 2. So if I move our h, let's move our h there, -3. So -3, and then it becomes plus. So remember, it's x minus h, right? So it's x minus h here. So when h is -3, the minus from the -3 and the minus from here give us a plus. So we've got our starting point here, and this is our key point we need to look at. Our starting point here is at -3 and 2. So if we like to have a look at that and say that our starting point will be at h and k. All right, so let's have a look at an example. Here we go, here's an example. All right, so sketch the graph of 3 outside of the square root of x plus 1 minus 6. All right, so our key thing is to see where our starting point. So we've got there and there. There's our h and our k. And key thing we're interested in is when x plus 1 is equal to 0. And that's when x is -1. So our start point is at -1 and -6. So if I go down the next page here, I'll be whacking a background that's I can just squeeze that in there. So we go -1 and -6. That's way down. Oh, you're not going to be able to see that down on the screen. Let me get rid of that particular one. Right. All right. So I'm just going to use this one. So -1 and -6. And so we have our starting point there. All right. So it's not a negative, so it hasn't been reflected. So it's going to go in the normal way. Now, we do have a dilation here, but when we work out our intercepts, the dilation is going to be used for that, and so that'll take that into account. So let's find the y-intercept first of all. And as usual, that's when x equals 0. So you put y equals 3 times 0 plus 1, the square root of, take 6, 3 times the square root of 1 takes 6. Square root of 1 is 1. 3 takes 6. Negative 3 for the y-intercept. So go to our graph. And negative 3 is our y-intercept. So we're starting here at negative 1 and negative 6. And we're intersecting here at negative 3. And then there's going to be a x-intercept over here somewhere. And so we can go back and we can work out what the x-intercept is. That's when y equals 0. So you got 0 equals 3 square root x plus 1 minus 6. Add 6 to both sides. Rearrange, now divide by 3. To get rid of the square root, we square both sides. Take 1. And that equals 3, the x-intercept. All right. So let's go over here. Y equals 3. X equals, oops, wrong colour from right there. X equals 3. So we've got one going there. So we've got a, whoops, that's not really very good, is it? Let's see if I can do that a bit better. Ugh, it's just as bad. All right. So anyway, curves around something like that. All right. Let's have a look at another example. Here we go. Sketch a graph of. So we've got our H and our K that we can go there. So our starting point, key point is at 1 and 3 that we're looking at. Then we've got a negative in here, so we know that it's reflected. So we know it's going down that way. And then we've got a dilation. And as before, that dilation will take care of itself when we work out the y-intercept. X equals 0. And the y minus, equals negative 2 square root 0 minus 1 plus 3. Y equals negative 2, the square root of minus 1 plus 3. Now we've got a problem here. And the problem is we're taking the square root of negative 1. And so square root of negative 1, there's no real solution. So what that means in terms of our graph is we have no y-intercept. Okay. All right, so when we get to sketching the graph, I'll talk a bit more about that. So x-intercept, y equals 0. So 0 equals negative 2 square root of x minus 1 plus 3. Take 3 from both sides. Divide by negative 2. The negatives cancel. 3 over 2 equals the square root of x minus 1. Get rid of the squared, we square root, I should say, we square. And so then we got 9 over 2 equals x minus 1. Go to the next page here. It's nearly disappearing off the bottom of the screen there. Sorry about that. And so we've got 9 over 2 is equal to x minus 1. Let me rewrite that. Whoops, 9 over 2. 9 over 2 equals x minus 1. Add 1 to both sides. 9 over 2 plus 1 equals x. 1, of course, is the same as 2 over 2. So our x-intercept then would be 11 over 2. All right. So let us go. And I'll put up that axis there. All right, so let's have a look. Here's our X, here's our Y. All right, right back here. So our starting point, 1 and 3. 1 and 3. So there's our starting point there at 1 and 3. Our Y-intercept, we didn't have any. Our X-intercept was 11 over 2. Now 11 over 2 is 5.5. Those have already figured it out. So that's over here somewhere. 2, 3, oops, wrong colour. 2, 3, 4, 5, 6. So our intercept is there at 11 over 2 and 0. And so our square root graph goes something like that. All right. So that took care of itself. All right. Now, the next thing that we might look at, and I'm going to need to use my calculator for this, is, okay, well, there's a negative out the front, and that, you know, reflects it down here. What about if the negative's inside? So what about then if I have, let's turn the square root of negative x, so the negative being inside. All right, so when I graph that, bingo, there we go. So this time we've got a reflection here in the y-axis. So it's reflected in the y-axis. So it's going the opposite way around. All right, so let's have a look at something with that. So let's have a look at here. So didn't take a very good photo there, but anyway. All right, so what we've got is y equals the square root of 2 minus x plus 3. So there's a negative there in front of the x. Now, the note underneath that, what that's talking about is if you take negative 1 as a common factor of our x take 2 take x, what it then becomes is x take 2. All right, and so excuse me, and so that's what we really need, because now we're going to look at our starting point. Because our starting point has to do with these two numbers. And so the starting point, the h, so x minus 2 is equal to 0 when x is 2, and the k, which is 3. So we've got our starting point. So our starting point, and this minus here, what that means, it goes this way. All right, when we work out some intercepts, that will help us out with that. So let's have a look at our y-intercept. And that happens when x equals 0. It doesn't matter which version you use. I'm going to use the original version. So y equals the square root of 2 minus 0 plus 3, square root of 2 plus 3. And I'm just going to leave it like that. You could do it as a decimal, but I'm not going to bother doing it as a decimal. I'll just leave it as an exact value. All right, our x-intercept, that's when y equals 0. And so we'll go 0 equals the square root of 2 minus x plus 3. Take 3 from both sides. It's the square root of 2 minus x. Then to get rid of the square root, we square both sides. So negative 3 squared, 2 minus x. I need to go to the next page before I disappear the bottom of the screen. So -3 squared, of course, is, whoops, too many pages, is 9. And so 9 equals, let me just go back, 2 minus x. Take 2 from both sides. And so then x, if we divide by -1, where am I? All right. Now, I've got myself a bit too excited here on this point here, because what I'm looking at is this line here. And I got all very excited and I went down to the next line. But I really should have looked at this line here. So what this line here says, and I'm going to erase the one underneath, so I want to write there. So what this right line here says is that the positive square root of some number is equal to -3. And this is where the problem lines. I just kind of got very excited about all of that, but not really actually thinking what this line here means. And it means that the positive square root of some number is going to be a negative. And the positive of a square root of some number can't be a negative. So what does that mean? Because I got all very excited. Let's just square both sides and everything. So that's not actually correct. And so we can't have the positive square root of some number equaling a negative. All right, so that can't happen. So what does that mean? That means no x-intercept. And so when we go to graph our thing, and this is what we graph it, here's the background, there it is. So when we go to graph our thing, so let's go back here. So we've got a starting point at 2 and 3. So starting point 2 and 3. So that's there. We've then got our y-intercept at square root 2 plus 3. So square root 2 plus 3. So there's 3 plus square root 2. Brings us up about here somewhere. So that's 0 and 3 plus square root 2. And it curves that way. So as you can see, it doesn't go through the x-axis, and so there's no x-intercept. So you need to just be a little bit careful there and not do the same thing that I did here and got very excited about. I'll just square both sides, but really need to think about what that actually means. All right. Because I would have got an answer of 7 or -7, which then would mean that the square root of 9 is equal to -3, which of course that is not true. It's a positive square root of 9. All right. So hopefully I haven't confused you a bit there. So what we've got then is we've got a key part is that this bit under here. So the key bit under here looks at what the allowable x values. Because these things here, whatever it is here, it's got to be positive. All right. So when you're looking at, say, I'll do it up the top here. So say y equals the square root of, say, x plus 3, for example, then what we know then is that x plus 3, it's got to be positive, but that's not quite correct because it can be 0, because the square root of 0 is 0. So what we do know about this x plus 3, it's got to be greater than or equal to 0. So if then we take 3 from both sides, we'd say then that x has got to be greater than or equal to -3. And so what these numbers here, this is called, would be the allowable x values. All right. And I think that covers it all. So what we're looking at now is exercise 4C. And so the questions you need to do are on your work plan. And if you need help, make sure you get onto me for that assistance.